Okay, Samarth, so you're having trouble with this problem. It says at 727 degrees Celsius and 1.23 atmospheres of total equilibrium pressure, SO3 gaseous dissociates, and you're given the equation. You're given that at equilibrium the density is 0.9 grams per liter, and you need to compute the degree of dissociation. So really what you need to be able to recognize here is the fact that because molar mass changes, or rather apparent molar mass changes, because now you've got some SO3, some SO2 and some oxygen at equilibrium, the number of moles of gas are different. Yeah, so as usual the first step is really to figure out what that relationship is. So we are given that this is the equation. Now assume you start with 1 mole of SO3. You got 0 0. This is before anything happens. At equilibrium, assume alpha, which is the degree of dissociation. Moles of SO3 dissociate, which means you've got alpha moles of SO2 and alpha by 2 moles of oxygen. Now the total number of moles is 1 minus alpha plus alpha by 2. That's a total of 1 plus alpha by 2 moles. That's the total number of moles you have. Now if you remember, I had explained, and I've put up a couple of other videos as well which explain how the molar mass changes. Yeah. So apparent molar mass at equilibrium, call that M prime, is equal to the molar mass of the starting material, which in this case is SO3, divided by the total number of moles. In this case that's 1 plus alpha by 2 at equilibrium. So now really the challenge for us, we know M because we are assuming we are starting off with 1 mole of SO2, so we can find molar mass for SO3. We can find the molar mass of sulfur trioxide SO3. So the challenge for us is to find M prime from the given data. Now if you remember from gaseous state, PV equals nRT. N is number of moles, which is equal to the mass or the weight of the mixture, whatever it is, divided by the apparent molar mass M prime, right? Put that in this equation and this gives you pressure times volume is equal to W by M prime RT, which implies that M prime is equal to weight by volume times RT by P. Now this term is nothing but density, and so this is equal to rho RT by P. You're given rho, you know what R is, you're given T, you're given P, you can find M prime. You know what M is, that's the molar mass of SO3. You've just calculated M prime, you know what M is, I'm sorry, and all you're left with is to calculate 1 plus, you're left to calculate alpha, I'm sorry, from this equation. So now again to repeat, PV equals nRT implies PV equals W by M prime RT implies M prime equals W by M RT, W by V RT by P, which is equal to rho RT by P. Also M prime, the apparent molar mass at equilibrium, is equal to what you start with, that's 1 mole of SO3 divided by the total number of moles that's left over at equilibrium, that's 1 plus alpha by 2. All you have to do now is solve for alpha. You've calculated M prime, you've calculated M. Let me know if there's still a problem.